Hi guys, welcome back for our math lesson for the day. So today you're going to need your pencil and you're going to need your math packet. Your math packet should be open to Thursday, March 26th. All right, let's get started. Okay. Moving so you can see this better. Great. So for the very first problem, you are going to be answering questions about the number 1,239,822. And you have a bunch of different questions that are asking you about the place value and the value, also asking you about the digit, doing some counting. I want you to take a look at all of these questions here, and I want you to answer all of the questions about 1,239,822. And we will come back and go over the answers in about 2 minutes. So go ahead and get started. About another 20 seconds. Okay, hopefully you've had enough time to answer most of these questions, so we can just jump right in. So the very first question says, what is the value of the 3? So we're talking about this digit here. In order to figure that out, you need to know that that 3 is in the 10,000s place, so the value would be 30,000. Awesome. The next one says, what is this number rounded to the nearest 10? That can be a tricky one. So for that, you have to look at the tens place and the ones place. So 1,239,822 is actually going to be closest to 1,239,820 because it's only 2 away from this group of 10, but I would have to add 8 more to get to 1,239,830. Definitely use a number line if that is confusing. Down here, the next one says, what is the number rounded to the nearest 100? So this is actually the spot where we have to look at the tens and the ones. The problem above, we could have just looked at the ones place, using the tens to help us figure out what our starting point and end point are. But for this one, it's really important that we look at the ones and the tens together, and then using the hundreds place to figure out our starting point and end point. So if I rounded this number to the nearest 100, I would round it to 1,239,800. And that's because it's only 22 jumps away from this number. But if I went to the next group of 100, which is 1,239,900, I would have to jump 78 times. So it's closer to it. Awesome. Skip count back by tens from this number. So that means I have my starting number, 1,239,822, and I am taking away tens each time. Double checking that's what it says. Yep. So now I have to count back by tens. So now it becomes 1,239,812 Taking away another 10, 1,239,802. And now I have to take away another 10, but I have a 0 in my tens place. So that means I have to regroup to get more from my hundreds place. So 10 less would be 1,239,792. And that would be 10 less. These questions are kind of tricky, but that's okay because we're working through them. Now we have to skip count forwards by thousands, which means the thousands place is changing. And right now in my number, I have 9 groups of 1,000, which means if I add one more, I have to do some regrouping. So let's put my starting number down here, 1,239,822. And if I'm adding 1,000, it's going to turn into 1,240,822. One more group of 1,000 would be 1,241,822 and 1,242,822. Notice the ones, tens, and hundreds are all staying the same. And that's because we're adding a larger place value. Write this number in expanded form. So hopefully for expanded form, you started with your millions. That 1 represents 1 million. Going into my thousands period, I have to add 200,000 and then adding 30,000 and then 9,000. Moving to my ones period, 800, 20, and 2. So there's that number in expanded form. And then what is 10,000 more than this number? So that means that it's 10,000. So I'm looking at that 3 and I'm adding another group of it. So that means I would have 1,249,822. And the last one says, what is 100,000 less than this number? I'm looking at this 2 in the 100,000s. Oh, you can't see it. Sorry about that. I'm looking at this 2 in the 100,000s place. 100,000 less would mean I have 1,139,822. With a starting number like this, where it has 7 digits, we just answered some really tricky questions about this. So if any part of this was confusing, definitely circle. If all of it was confusing, circle the whole thing. But if specific parts were confusing, maybe the rounding was confusing or figuring out 100,000 less, just circle those so that you can go over them with your teacher. Awesome. Now we're going to take a look at the problem at the bottom of this page. It says there are 9 students sitting at a lunch table. There are 7 lunch tables in the cafeteria. How many children are in the cafeteria? Write a number sentence and solve. I also want to push you to using a key. We'll be going over what the key should look like after you guys have some work time, but definitely draw a key so that you understand what your numbers in the problem represent. Take a couple of minutes to solve. Okay, we're going to pause right here. All right, so the first thing I talked about us doing, and I'm going to just use my whole board to solve, so let me zoom out so you can see it, is a key. It's really important that you understand what these numbers represent. So I have the number 9, I have the number 7, and I have a question mark, something that I am solving for. So in here I can see that 9 represents students at each table, using some abbreviations here. And the next one says there are 7 lunch tables. So this would be the number of tables. And I have to figure out the total number of students. So as you can see here, and hopefully you wrote a number sentence that represents this, this is an equal group problem because I have a certain number of students sitting at lunch tables, I have a number of tables, and I have to figure out how many total students I have. So instead of being division like we've been practicing the past couple of days, this is actually going to be multiplication. 9, I actually want to start with 7. 7 times 9 equals something. Now the reason why I'm starting my number sentence with 7 is because multiplication means you have groups of. So I have 7 groups of 9 in this problem, where the 7 represents the number of tables. So I have 7 tables with 9 in each. So 7 times 9 would represent this problem, but you could also use you could use the opposite multiplication number sentence to solve as well. It's really your choice. Now for me, I really like the strategy of doing a repeated addition and then solving with the mental math doubles facts. But here you could draw a picture, you could draw an array, you could do some skip counting, although skip counting by 7 or 9 is a little bit tricky. So let's do some mental math and do repeated addition. 7 groups of 9 means I have 9 plus 9 plus 9 plus 9 plus 9 plus 9 plus 9 equals something. And then we double check, I didn't forget a 9. 1, 2, 3, 4, 5, 6, 7. 7 groups with 9 in each. So now I'm going to add 2 9s at a time. 9 plus 9 is 18. 9 plus 9 is 18. 9 plus 9 is 18. And I have 1 more 9 left. So now I can work on 18 plus 18. Well, 10 plus 10 is 20. 8 plus 8 is 16. 20 plus 16 is 36. And now I have to add 18 and 9. 18 plus 9 you could count up on your fingers to solve, or you can think about 9 like the number 10. That's just one more. So I know that 18 plus 10 is 28, but now I have to subtract 1 to make it actually the correct answer of 27. If that was a little challenging for you, definitely make sure that you use a strategy that works for you. Algorithm, base 10, counting in your head, whatever works. Now I have to add these two numbers together. So 36 and 27. Let's do a quick algorithm. Making sure you guys can see it. I'm very much slanted here. 36 plus 27. 6 and 7 is 13. 3 ones, regroup 10 ones into the tens place. 1 plus 3 is 4. 4 plus 2 is 6. So your answer here is 63. So 7 groups of 9 is 63. Again, if this is challenging for you, please circle it. You can go over division strategies and number sentences with, not division, multiplication, number sentences with your teacher when you check in with them. Awesome. Turn your page. Let's go to the back. So there are a couple, we have 1, 2, 3, 4, 5 more problems here. I'm not sure if we're going to get to all of them just because we've already spent a lot of time on our math, and I want to make sure that we're not doing too much and we're all staying focused. So for the time being, what I would like us to do is I would like us to work on number 3. So number 3 says, Mr. Scott invited 27 friends to play board games this weekend. Each board game requires 3 players. How many board games will Mr. Scott have to get? Write a number sentence and solve it using any strategy. So for this one, again, I know it doesn't tell you to do this, but I want to push you to draw a key, especially if these word problems, addition problems, subtraction problems, multiplication, division, especially if they've been difficult. I want to push you to use a key so that you're really understanding what these what these numbers represent. Take a couple minutes and go ahead and solve. Think about 30 more seconds. Okay, we're going to stop here and let's go over this problem. So again, we talked about making sure we have a key. So the numbers in my key are 27, 3, and question mark. 27 represents the total number of friends. So total friends that Mr. Scott is inviting over. And then 3 represents 3 represents the number of players for each game. And we have to figure out the number of games. Okay, so hopefully you figured out that this was an equal group problem, but instead of being multiplication like the last problem, it's actually going to be division. So that means I have 27 and I'm dividing it by 3 to get my answer. Now we're missing our number of groups. So I'm going to go and use that strategy we've been using the past couple of days where I have to draw out my total number of my total. So that's 27. So I need to draw 27 circles. Remember, I do them in groups of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. One more would make 10. And I'm going to draw 27 of them. So here's 20, 4, 5, 6, 7. Plenty of space between them so I can see. I'm going to grab a different marker because now my job is to figure out how many groups I have, how many games I need. I know that I have to circle groups of 3 because there are 3 in each. So 1, 2, 3. So that's 1 game. 1, 2, 3. That's 2 games. 1, 2, 3. 3 games. 1, 2, 3. 4. 1, 2, 3. That's 5 games. 1, 2, 3. That's 6 games. 1, 2, 3. 7 games. 1, 2, 3. 8 games, 1, 2, 3, 9 games. So that means that I would need 9 games, or Mr. Scott would need 9 games in order for everyone to be playing something. Wonderful. We are going to, let's see, what time do we have? We are going to hold off on number 4, and I want us to take a look at number 5. So we're skipping number 4, and we're going to go to number 5. So number 5 says, and I'll zoom in for this one because this is a good problem to work on together. Da, da, da. I know it's been over a week, but I'm still figuring out all this camera stuff. Okay, It says Robert has 16 signed baseballs. Anthony has 11 signed baseballs. Which number sentence can be used to find out how many more baseballs Robert has than Anthony? So it's not asking you to solve here, but it's asking you to figure out a number sentence that would help you figure out how many more, this is super important, how many more baseballs Robert would have than Anthony. So in order to do that, you need to understand what how many more represents. Right now, take some time. Whenever you have to figure out which number sentence would represent something, do the work yourself. So if you were solving this, what number sentence would you use? And then figure out which answer here you would circle. Go ahead. Okay, I'm going to model a little bit on my board here. So again, this is a problem that you could draw out a key if you want to, and I'm even going to use a model here. So for my model, I don't know why this is a little blurry. There we go. All right. For my model, I need to represent, I have Anthony, and he has 11 baseballs, and Robert, who has 16. So I'm going to draw a comparison bar model. This is something you guys learned how to do in first grade. My first bar, my biggest bar on top, is going to represent Robert because Robert has the biggest number. And R stands for Robert. He has 16. Anthony, his bar is going to be smaller because Anthony only has 11. And this space in between here represents what we're solving for. This is called the difference. And when you're finding the difference between two numbers, you have to do subtraction. So the way that you would do this is you would do 16 minus 11 equals something. There is an addition number sentence that you could also use, and that would be 11 plus something equals 16. Both of these are in the same fact family. They have the same total, 16, 16, and the same parts, 11 and something, 11 and something. So now that we've done the work and we have our answer here, take a look at the problem. Which number sentence is the only one that would make sense? 11 minus 16? Nope. A is wrong. B is wrong. C is wrong. The only one that is right is D. So hopefully you realize that if you're answering this problem, the number sentence that is there for number D, which is right here, is the only one that would work. Great. To finish up math today, let's work on number 6 and number 7. So you're counting on by threes, getting that practice. So take about 30 seconds to count on by threes and counting on by fours for number 7. Go ahead. Okay. Counting on by 3, starting at 0 goes 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Counting on by 4s would be 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. All right, so zoom out a little bit. Oh, not in, out. There you have it. So that's today's math lesson. We did skip a problem. If you have extra time today and you want to solve it, definitely go ahead and solve it on your own, and you can check in with your teacher about what the right answer is. But if any of these problems were confusing, make sure that you circle it so that you can touch base with your teacher about it when you talk next. I hope you guys have a wonderful rest of your day, and I will see you tomorrow with a new math video.